In this second part of the lesson, Is the Matter Around Us Pure? We would be talking on various separating methods which can be deployed to separate components of a mixture. In this presentation, we would see techniques like evaporation and centrifugation. Please go through the following points, which are a recap of the concepts learned earlier in this lesson. After this, we will move ahead to study various separation processes to separate components of a mixture. We have studied mixture which are made up of more than one type of substance. If we want to separate these components of a mixture, what are the simple physical techniques that we can use? Now, if the mixture is a heterogeneous mixture, then we can deploy some simple physical techniques. You can see 4 different techniques on the slide. Can you identify them? You have already studied this in your previous classes. These are the techniques which can be deployed in our day-to-day life. In the previous slide, we have seen that if the mixture is a heterogeneous mixture, then its components can be easily separated by physical methods like you can handpick, sieve, filtration, and all these are readily seen in our day-to-day life. However, if the mixture is not a heterogeneous mixture, then we have to use various techniques. Let us study first about evaporation. Now, evaporation, it has a mixture. Let us take an example of dye. A dye which has two components. One which is solute, which is non-volatile, and second which is solvent, that is volatile. So, the principle that I am using over here is that I can separate the volatile component from the non-volatile component by a method of evaporation. The flowchart on the right hand side of the slide tells you how that process can be functional in a laboratory. Like I take ink in a watch glass and then I try to place the watch glass on a beaker which is half filled with water and I heat the beaker. I see certain vapors coming out from the glass and I will stop this when no more of such vapors are seen. What remains in the watch glass will be ink, that is a residue left in the dye because all that water has now been evaporated. Thus, I can conclude that ink is a mixture of dye in water. I want you to think, where do you think this method of separation is useful on a large scale? Also, the slide gives you a hyperlink down there. Please see that video for yourself to understand the process better. Let us look into second method of separation of mixtures, centrifugation. This is useful when a mixture has small solid particles and they cannot be separated using filtration techniques. Such type of mixtures we need to deploy centrifugation to separate its components. The principle that is used is the mixture is spun rapidly and that because of that motion the denser particles are forced to move to the bottom and the lighter particles stay at the top. The picture on the right hand side of the slide will tell you how the suspended particles, supernatant and the pellet particles are seen after they have been run rapidly using a rotating motor. This method is applicable to separate components of blood. I'm sure you recollect what are the different components of blood in, and this is very essential to separate them if we want to run a blood or a urine diagnostic study. Same way, in the market we get full cream or toned milk or various varieties of skimmed milk. How do you think these are separated? How do you think the components of fat in the milk is separated? it is based on this technique. Think, where else is this method deployed on a daily basis in your home? There is also a link that is given that will help you to visualize how centrifugation actually works. Please go through it.